everyone, Rhoda here with a JAC capsule about logarithms. We're going to go through the properties of logarithms. Whenever you're thinking about logarithms, it helps to go back to basics and remember how they're defined, which is as the inverse of an exponential function with the same base. Here's that relationship written out. So if it's true that y is equal to a to the power of x, that means it also has to be true that log base a of y is equal to x. What you should see here is that on the left-hand side, I'm inputting a value of x, and I'm getting out as an output whatever y is equal to. And on the right-hand side, when we move to the logarithm of the same base, the y and the x got exchanged. So y became my input, the thing you plug in, and x became my output, the answer that you get. So x and y, or the input and output, are swapped. That's what I want you to keep in mind. So now if I look at properties that I already know for exponentials, and I keep in mind the input and the output should get swapped, I should be able to make sense of some properties for logarithms. So let's go through these one at a time. My first property or fact about exponentials is that any base a raised to the power of 0 gives me 1. So in this context, my input is 0 and my output is 1. When I switch that to a fact about logarithms, I would swap those. So I would be plugging in a value of 1 to my logarithm, and I'd be getting out an answer of 0. So it's always true for any base a that log of 1 is equal to 0. My second property is very similar. This time I'm plugging in a value of 1 to my exponent, and I'm noticing that any base a to the power of 1 would just give you a back again. When I translate that into a statement about logarithms, it would say that log base a of a is equal to 1, and that's true for any value of a. So a special case of that to keep in mind, if the base is e, we write it as ln. Ln of e would be equal to 1 because ln is the same thing as log base e. That's a good one to keep in mind as a special case. Next one. Now we're getting into the actual properties, the things that would help you rewrite an expression or solve an equation. On the right-hand side for exponents, we know that any base a raised to the power of x plus y can be rewritten as a product of a to the power of x times a to the power of y. If you're rusty on this, we do have a whole playlist about working with exponents. But what I notice here is that in the input, I have an addition, which becomes a product outside of the exponent. The corresponding property for logarithms looks like this. So what can you notice here? For exponents, I had a sum on the inside of my function, which became a product on the outside. Now for logarithms, that's flipped. I have a product when I'm inside the logarithm, which becomes a sum when I'm outside the logarithm. So that inverse property is showing up here. And that might help you remember or make a little bit of sense of this logarithm property. Same goes for number 4. In number 4, for the exponential expression, I have x minus y on the inside. So I have a difference on the inside, which according to the property becomes a division on the outside. So what do you think will happen with a logarithm? The logarithmic property will be the inverse of this. So on the inside of my logarithm, I would have a division, which gets split up into a subtraction that happens outside of the logarithms. So that's my corresponding property number 4. Last one, in property 5 for exponents, we have a to the power of a product. So on the inside, we have x times y. And that y comes outside the exponentiation as its own extra exponent. So on the outside, we get an exponentiation. This will be flipped for the logarithmic property. Instead of the extra exponent being on the outside, it's on the inside. That shows up like this. Log base a of x to the power of y equals, now for the exponent side, we had a product on the inside. Now that product will come outside. So it's equal to y times log base a of x. That y comes out front as a product. these are the main properties of logarithms. There is one more that I'll just mention very quickly. It's not so relevant for your calculus class. It's mainly important when you're trying to rewrite your answer in a different way. If you have log base a of some number b, you can actually rewrite that as log of b over log of a. Now you'll notice I didn't write a base yet. I can use whatever base I choose. So that's another property that you might need to know, but it doesn't show up so much in calculus class. All right, in the next video, we'll try to use these properties to solve some problems.